Mathematical Comparisons on an International Assessment, highlighting the correlation of calculator use to student achievement, presented by Parker-Holliman, a graduate student at Texas Tech University. Educators today are faced with the opportunity and challenge to prepare all students for mathematical advancements of the future and to equip students to compete internationally. This study is focused on technology integration and how that creates a significance among student achievement. The technology integration of focus is that of the calculator within a mathematics classroom. Does calculators help or hinder students' learning of mathematics? This achievement will be analyzed and compared with students who had limited use of calculators and those who had full access and use of calculators in the mathematics classroom. Data from this study was taken from the TALIS-PISA Data set, which provides valuable information about teaching strategies and their correlation with school characteristics, the classroom, and student outcomes. Research questions involved in this study include: what correlation, if any, is there between student calculator use in the classroom to their mathematics achievement levels? Secondarily, we looked at the question, does the access of technology in the form of calculators in mathematics classroom predict heightened mathematical achievement? The theoretical framework outlined within this study includes that of constructivism. In the article, Learning Through Information Communication Technology, Silverson outlines the two prominent positions among constructivism which together overlap in context, which includes constructivism and social cultural theory. These theories represent a medium in which students are participants in a supportive learning environment and are active in their own learning. Innovation of new learning occurs best when it's put into context to hold relevance to the student. Several researchers in the field of mathematics education all agree that technology is an integral component of educational change. There is also an abundance of research that shows mathematics instruction that focuses and builds on students' personal sense-making produces in the end powerful mathematical thinkers who can compute and have strong conceptions of mathematics and problem-solving skills. Today, there is a lot of research that points in the direction of how math ed can benefit from technology such as calculators. But this is not a new frame of thought. Dating back to 1916 with John Dewey, who proposed that education needs to adopt new instructional approaches based on the needs of the future. This is not a new notion. It dates back several years. The literature review within this study included research from the Journal for Research in Mathematics Education, which stated, with growing international competition for science and technology jobs, the mathematics achievement of American students has become increasingly important over the last 2 decades. In an article entitled, Teach Up for Excellence, All Students Deserve Equitable Access to an Engaging and Rigorous Curriculum, in the journal Educational Leadership, 2 scholars, Thomason and Javis, makes a promising point of view stating all students deserve equitable access to an engaging, innovative, and rigorous curriculum. A technology-integrated curriculum can be accessible to learners at many different readiness levels. Another scholarly author in the American International Journal of Contemporary Research suggests the use of innovation in the form of calculators does not negatively affect students' learning. Students will not lose their ability to think if they were to use a graphing calculator. A promising article entitled 7 Habits of Effective Teachers suggests students develop their own talents over the long haul when they are both intrinsically and extrinsically motivated. Classrooms should be places of innovation where students can thrive by challenging themselves to learn in new ways. And dating back to 1986, Hembry and Desert conducted a landmark study that showcased the benefits and disadvantages of calculators being used in mathematics classroom. This meta-analysis study integrated the findings of 79 studies with 6 calculators on student achievement. 2 factors had affected the performance of students in classes taught with and without calculators. 1 included the allowance or not of the calculator during the outcomes test, and 2, the types of tests on computations. These 2 scholars found that the use of calculators during instruction does not hold back computational skills and conceptual understanding. Furthermore, this use of technology increases outcomes on non-calculator tests, both computationally and conceptually. This study is a product of the analysis of the Teaching and Learning International Survey Program for International Student Assessment. I also used the Teacher Mathematics and Science module, an international survey that examines mathematics educational environments. The methodology used within this study included the use of this TALIS-PISA data set with the IBM statistical package for social sciences, which was employed as a tool to manage, perform data manipulations, and create statistical displays for presentation. IBM SPSS is a comprehensive system used to analyze data. The data used for this research study is an international data set available online for public access. The process to download the data set from the Teaching and Learning International Survey Mathematics Teacher module to my computer included ensuring the appropriate data set corresponds to the question I used to tailor this study. The items and questions of focus for this study included: which of the following best describes the achievement level of students, which has the identifier of TT2MO4? And also the question, how often do students have calculators available for use in their mathematics assignments? Item number TT2M10. According to our course textbook, authored by Julie Patton, SPSS Survival Manual 5th edition, non-parametric techniques are ideal for data sets such as the TALIS-PISA set that I chose for this study. The Pearson chi-square for independence was selected as the non-parametric technique used. Based on the qualitative categorical variables within this study, the characteristics of the data, and my desire to explore the relationship in the form of a correlation between them. Lastly, I created a cross-tabulation of this data. The cross-tabulation was administered to find the percentage of each category response for the 2 questions within this study. At the onset of this study, there was an interest in obtaining a correlation among the teachers' perspectives of students' academic achievement and their level of use of calculators within the classroom. The cross-tabulation was used to look at the summary of information contained in the data, which included 5,177 valid cases. For the students considered by their classroom teacher to be low achieving in mathematics, many of those students found the most success when they had frequent access to a calculator. Although the distribution of low achieving students within the cross-tabulation remained within 1/10 of a percentage point of significance, students in this low achieving group shared similar means when looking at calculator use that was occasional or all to nearly all of the time within the classroom. Among this low-achieving group, the largest difference came about when the students never or almost never used a calculator. There is a 10 to 16% decline in the difference of the number of students who never or almost never use a calculator in comparison to those who use it frequently within this low-achieving group. Moving on to the other three groups, we found similar patterns of ascending percentages that lends itself to highest percentages resulting in students who performed their best when they used a calculator in all or nearly all of the assignments. The residual percentage descends as the use of calculator declines in the classroom. The largest percentage of students, which are those of high achievement, with use of a calculator in all or nearly all of their assignments, have the largest range compared to the average and mixed achievement level groups in each of these calculator use categories. The high achieving group, most teachers on average perceive to have had the largest range in percentage of the population compared to those who never used a calculator in the classroom or those who use this tool in nearly all or on all assignments. The chi-square test, which indicates 0 cells, have expected count of less than 5. The Pearson chi-square value is 180 and 505 thousandths, with a significance of 0. Within the symmetric measure, the pi coefficient value is 187 thousandths. A chi-square test for independence indicates that there is very strong evidence that there is a significant association between student academic mathematical achievement and the use of calculators. This study relies heavily on teacher perspective and self-reporting. Given the degrees of freedom within this study, one can conclude there are several factors that contribute to this limitation that allows for variation. A second limitation is that this data is only taken from secondary teachers and students. Therefore, this research study does not exhibit results as it relates to elementary students and teachers. Lastly, there is a disproportionality of valid cases compared to those that were missing in this study. With an average of 19% of the cases valid and 81% missing from this TALIS data set for science and mathematics, one may place the limitation of validity and reliability on this data given the large percentage of undocumented data for this survey. Upon concluding this research, one may wonder why there are so few data entries within this math and science survey. Let's work together to form the direction of mathematics education. Based on the research, technology has infiltrated all aspects of the modern lives, and classrooms are no exception. The direct connection with technology is an added benefit in the implementation of mathematics instruction and has possibility for the future. This study supports previous research by NCTM and leaders in the field of math ed, suggesting technology integration has the potential to create higher achievement of all students in mathematics. The percentage of students who are considered high achievers use calculators in the math classroom nearly all or all of the time. In addition, those who were not categorized by their teachers as high achievers in this study showed evidence that when calculator use was evident, the percentage correlated to an increase in their achievement. Here are the references that accompany my presentation. Thank you.